Today's video is going to be about inscribed quadrilaterals, things that look like this, where you've got a quadrilateral inside of a circle. Notice that all the vertices are touching the circle. In particular, this is going to help you with IXL skill U.11. So go ahead, and you might want to bounce back and forth today. You maybe do some IXL, jump back to the video. But anyway, let's just get started on the first problem. So here's a typical problem you might run into where we have this quadrilateral and we've been told one of the angles. In particular, this angle right here, angle V, is 64 degrees. And if we remember from before, this angle is going to correspond to the arc length over here. In other words, from U to W. And remember from this, we know that the arc length here, the measure will be actually double the 64 degrees. In other words, the measure of it. So double 64 would be 128, right? So the measure of 128, in other words, if I drew an angle right here from the center of the circle, that angle would be 128 degrees, which also is what we describe the arc measure to be. Now, if we look at the full circle, we know that a full circle has 360 degrees. So if we think about the measure of the major arc, right, this is the minor arc, the major arc from U to W, which we would call UVW, because it's going this way, is going to be 360 minus 128. So if we were to look at this guy over here, right, 360 degrees minus 128, right? So that would be, right, let's see, that's a 15, actually just a 5, excuse me. We got a 3, and then we've got 232 degrees, right? So 232 degrees from here all the way around to there, okay? All right, so that's 232. If we then work back, what's going to happen here? Now, here's a circle. I've actually written it twice, and we're going to use it two different ways here. But if we were to look at angle A, now I'm just, to make it easier to describe things, I'm going to use some variables. So A is going to be this angle measure. We're going to have B, C, and D. So I'm just using lowercase letters so I don't have to keep writing measure all the time. Okay, now notice that angle A, like we did just a second ago, we know that if we look at this arc over here, right, that A is going to be half of the measure of that arc. Okay, so I'm going to write this out. I'm going to say A, and I'm going to leave some space. You'll see in a minute why. A is equal to 1/2 of the measure of that arc. 1/2 of that, and right, so the measure of that arc, right, the measure of arc BD. Okay, all right, so I'm just trying to be explicit in my reasoning. Same thing happens with C over here, doesn't it, right? So if I think about C, right, here's C, and I'm going to look at this arc on the other side, right? So it turns out that C is 1/2 of the measure of the other one, DAB, right? So DAB, right? And if you remember from before, right, if it's a minor arc, we just can use the two letters. If it's a major arc, we have to show that we're going around the whole thing. And that's, to me, it looks like that one's definitely a major arc. So that's why I wrote it that way. But let's think about this for example. Look, this is all the way around. Well, sure, I could write it down. Look, that's just 360 degrees, isn't it? Right? That's 360. Right? A plus C, well, half of 360, that's 180. Okay. So what I just figured out here is, look, I got rid of all the specifics. Look, this is true no matter what, right? If I generalize this to any inscribed quadrilateral, it's going to be 180. And you know, it works on the other way too, right? If we look at this other circle, right, let's just look at D and B, and this time what I've got, right, is I've got this arc and this arc, right? And again, that's going to add up to 360. We can use the same logic we used a second ago, and we're going to get the same thing, but now for the other angles. So I would have D plus B equals 180 degrees, okay? This is really handy. It's going to be true for any inscribed quadrilateral. So we can generalize this, and if we want to say it in words, we can say that the opposite angles of inscribed quadrilaterals, and it's really important that we say inscribed quadrilaterals, not just any quadrilaterals, and I'll show you in a second why that's true, right, are supplementary, right? Okay, now think about for a second, supplementary, don't confuse it with complementary. Those, we have 180 degrees. They add up to 180 degrees, right? So this is an important theorem that comes in handy. And again, let's just convince ourselves for a second, right? This is only if it's inscribed in a circle, right? So this is the same one we got here a second ago. Now, just for a second, imagine I extended this guy out here and I drew a different quadrilateral, okay? Right? So let's see, this was A, B, C, D. Let's call this guy E up here, right? If I had a different quadrilateral, which looks just like this one, but now it's E. Now look, if D plus B are equal to 180, suddenly E is changed, right? Look, E is definitely smaller than this angle B. Well, I can guarantee that D and E don't add up to 180, right? Because I knew that D and B did. So again, this only works if the quadrilateral is inscribed in a circle. Don't get carried away and say, well, for just any old quadrilateral. Okay, great. So now we've got this cool property of quadrilaterals in circles. Let's use it a couple times. Let's use it now on another one. Now you're going to run into some problems where we've got multiple angles you're going to have to find, right? So look, I'm trying to find both measure R, which is up here, right? Here's measure R, and I'm also going to use it to find measure S, which is over here, okay? Now, you just got to remember that it's opposite, right? So this 103 goes with that one, the 92 goes with that one, right? So again, it's just for the opposite one. So if I want to figure out what the measure of angle R is, all I have to do is say, well, look, that's just 180 minus 92, right? So this is 180 minus 92. Well, 180 minus 2 is just equal to 88 degrees, okay? So the measure of angle R is just 88 degrees. Same thing for this angle S, right? So this one, just going to say 180 minus 103. Well, 180 minus 103 is just 77 degrees. So measure of angle S, the one over here, is just 77 degrees, okay? So again, you just ignore part of the circle. Just think about these two, think about these two. That's how you're going to do it. You're just going to break it into pieces. All right. Well, just because we like a little challenge, we're going to have some problems that have some algebra calculations coming into play. So here, I've got an x involved, right? So look, I've got this x I have to find. Now this time, I'm not directly finding the angle, I'm finding the variable. And so all we have to do is just remember that, look, these two guys go together because they are opposite, right? Now sometimes you're going to have some extra numbers. Just ignore those. Only think about the ones that are opposite. So I can just write that out as a nice equation, right? So I end up with x plus 76, right? So that's this first one, right? Plus 94 is going to equal 180. Okay, now if I add 76 and 94, I'm going to get x plus 170, right? 170. All I got to do now is, let's do some solving, right? minus 170, minus 170, right? And you're going to finally get x equal to 10. X equal to 10. Now, let's look back at this, right? That means, look at that it's in degrees. So really this should be x equals 10 degrees, but that would be your answer. What is x, all right? Sometimes we're going to have a couple of angles. So in this case, all right, there's a lot going on here. You know, now I've got two variables. I got to get both x and y. Again, just, you know, set it up. Think, okay, these two angles go together because they're opposite, and then these two angles go together, right? So this is essentially two problems. The trick is you just got to make sure you keep them separate, right? So in this case, you know, if I'm doing these guys, the ones that I highlighted in red, I've got 5x plus 7x, right? And that equals 180. So I get 12x equals 180. When I solve that, I'll eventually get x equals 15 degrees. Okay, so that gives me x 15 degrees. Y, on the other hand, got a different equation. I've got 17y plus 95 equals 180. When I work all that out, I'm going to subtract 95. I get 17y equals 85. Divide by 17, both sides, and I finally get y equals 5 degrees. Okay? So again, notice they're asking the variables, not the angles. So make sure you're solving the equation. And so I would have y equals 5. All right, well that's it for today. And enjoy your IXLs.